coding simplified with Vandana, number system conversion. The third one is the decimal to hexadecimal conversion. Just a quick recap, we have already completed decimal to binary. Then we have also done decimal to octal. And now this is the third one, decimal to hexadecimal. We'll take the same example, the number 425, which is a decimal number, and now it needs to be converted to a hexadecimal number. So the same repeated division method, we will write the number 425, the decimal number over here, and now we have to divide this repeatedly. So since we are going to convert this to hexadecimal, so you must have guessed it, we are going to divide it by the base of hexadecimal number system, that is 16. Remember, when we converted decimal to binary, we divided by 2. When we converted decimal to octal, we divided by 8. And now we are going to convert decimal to hexadecimal, so we are going to divide this by 16. So let's continue. 425 divided by 16. So we are going to start from 42 divided by 16. So we get 2 over here because 16 2s are 32. So 42 minus 32 is 10. So we have a carryover of 10. So this becomes 105. Next we have 16 6s. So you can just check it out. That's 96. So 105 minus 96 becomes 9. So the remainder is 9. We'll continue this process. Again, we're going to divide it by 16. So now we have 16 ones are 16. 26 minus 16 will become 10. So we have a remainder of 10. Finally, we're going to stop here because this number 1 is less than 16. So it will be shifted over here and 1 will be written this side. Now, again, we'll continue with the same process as we've been doing till now. That is, writing the answer in the reverse manner. With this being the most significant bit, the leftmost bit, that's 1, and the rightmost bit, 9, this is the least significant bit, which will become the rightmost bit. Okay, now as compared to the previous conversions that we did with binary and octal, now since this is the hexadecimal number system, and I hope if you have not forgotten, the numbers, the digits are something like this. From 0 to 9, we have all digits. Then we have the letters as A, B, C, D, E, and F. So actually, in place of the number 10, we have a hexadecimal letter A. In place of 11, we have B. In place of 12, we have C. In place of 13, we have D. In place of 14, we have E. And in place of 15, we have F. So we just need to convert this in that specific hexadecimal format. So 9 and 1, there's no issue with the number 9, with the digit 9 and the digit 1. But this 1, 0, 10. So 10, as you can see from here, this will be replaced by the letter A. So this will be replaced by the letter A. And now the answer. That means the hexadecimal equivalent for this particular decimal number 425 is 1A9. This is the hexadecimal equivalent. Remember, we have written it in the reverse order. 1. In place of 10, we've written A and the number 9. So 1A9. This is the hexadecimal equivalent for this given decimal number 425. Let's continue with the fractional discussion also. So if, for example, the given number was 425.75, that was the decimal number, to be converted to hexadecimal number. So the integer part has already been converted. So this integer part gives you the answer 1A9. Now After the decimal point, the fractional part has to be converted. So we'll begin with this. 0.75 will be multiplied by. Now, remember, in case of decimal to binary, we multiplied the fractional part by 2. In case of decimal to octal, we multiplied the fractional part by 8. So now in this case, since we're dealing with hexadecimal, we will multiply the fractional part by 16. So let's do this quickly. So we have 0.75 into 16, that comes out to be 12.00. All right, so we have to be concerned with the integer part over here, which will be shifted to the answer. So here we will have to write 12. Now again, remember, being a hexadecimal number system, 12 means we are going to refer to the letter C. So in place of 12, we will write C like this. And we'll stop this process over here because now the fractional part, the leftover fractional part is 0. So we cannot continue further. So this is the complete hexadecimal equivalent for this given decimal number 425.75. The hexadecimal equivalent is 1A9.C.